surplus to requirements. Again, in this one, same thing. Measuring an angle to a star, sod all to do with the globe Earth I'm going to dissect, even though they've rubbed out the line, and everything to do with this flat plane. So it doesn't matter. This could be all the way out to here, and you'd still be dissecting it and ignoring it completely, the sphere in the middle, I mean. Doesn't matter if it comes out to here, here, here. It's never used.
Bottom half of a dingleberry. It's just the top half.
No, but it states in the middle, doesn't it? What I was saying.
Gone.
States what's actually going off there. Observer.
Yeah, the observer, yes.
Center of a Scotch egg or anything. It's just the observer, where the observer is positioned. That's how the celestial sphere manifests above the observer.
But the observer is on a flat plane.
Always.
As shown there.
Yeah. All right.
It's a flat
Next
plane
slide.
burger.
Well, the sphere we're seeing is the sphere of perspective of his eye.
No,
That's why it's spherical.
right. It's confusion that's now become apparent just by your last comment. There is two spheres, right? What we have on screen now, as Adam's just detailed, is the plane we stand on with an observer view of the sky. Now, I say specifically observer view because the sky, in terms of how this is actually going to be calculable, is parallel to the ground based on how you're going to be utilising it. But given that parallel position of the sky and the lights in it to the flat ground you're standing on, when you look at something further away, it will drop towards the horizon, right? You notice how on the outside edge of this flat plane we've got a horizon line? That's where this arc meets, because that's the arc of your perspective view on a plane to the sky. In other words, there is no globe in this perspective view. Now, when we move over to this depiction, the representation that was actually given to you is the secondary side slanted dome of the sky. So this green dome here is the actual representation of this dome of the sky, right? And this plane that it's got marked as horizon with the observer point in the middle matches up with this line around the outside edge. So you can probably see where I'm going with this. The sphere inside it is surplus to requirements, because all you're going to do is move the angle down to this plane to actually do the angles and make them work off the plane that you're actually using. Ergo, the sphere inside is surplus to requirements. This bit, however, the representation of the sky, and this bit, the representation of the plane that you're standing on, is actually what's used. So when we move back, this is my actual point I'm getting to. When we look at this view, this in no way, shape or form represents some sphere of the Earth. The only bit that's representing the Earth in this view is the bit marked observer with a flat plane marked horizon surrounding it. This is a flat plane. And this is the sky. So where's the globe bit? Well, there isn't a globe bit.
Well said.
Yeah, and the flat plane matches the flat sky. There is no sphere on the ground or even in the sky. That's the important bit for me. That I had to distinguish. You're constantly trying to, because that's how you see it, reconcile that it's curving over your head like a dome, Neil. You know what I mean? But it's not. It's flat. It's only the shape of our eyes.
If you were stood underneath a bridge, a very, very long suspension bridge, imagine yourself underneath it. As you look to your left and to your right, it will arc over you in your perspective view. and you can measure the angles to it holding a protractor underneath the bridge. But every height of the bridge all along the top of you is all the same height. But from your point of view, you've got a dome of the bridge above you? No, you haven't. That's just your perspective view. And it's no different with the stars, but when projected out from one point, the stars that are further away over a piece of land over there has dropped towards the horizon in your view. Ergo, you end up with a dome representation of how the stars present themselves to you from a single observer point with an equal distance circle all the way around you. So, as Adam said, and we've stressed it 3 times, that means that you've got a flat line of lights presented to you.
So it's all about perspective then.
Yes, it always was. We just didn't dig deep enough when we called the perspective hijacking Earth curve calculator as such. Goes much deeper, doesn't it? Exciting, isn't it? This is how we got swindled. I love it. I'm way past it,
Very
though.
educational.
For those of you who are crapping your pants because you're a globe believer and you can't quite, and you're smart enough to follow along with this stuff, then you might suddenly have a cold shiver. For me, I just laugh. How long past this? It's just a folly almost to me now. I don't know about you, Adam. You're probably more into it for the mathematical brilliance of it. But to me, it's just an interesting folly how they duped the current Western world society into this religion. It's just an amusing folly to me.
Yeah, it's a challenge, particularly celestial navigation, trying to understand it, because it's all about transposing numbers. And it interests me as to show how much I got mugged off and how I'm described there. Even now, trying to think that it is a flat plane, but the way in which the number and the data has always been presented was to form a ball. So it's very interesting unpicking that mathematically and in your own head. You see how deep the programming is. Every single bit of this is building a ball, but none of it ever represented a ball, as we're finding out. Yeah, that's what was insinuated to us.
But there's a live stream queue. So if, as it is the case now, we've got more participants than the room allows, you can just join the queue, and obviously I've got to pay attention, or one of my mods will pay attention and move you in and then take you off mute so you can join in the discussion. This is an open forum, open to the public while the show is live. So while we're discussing this and debating amongst ourselves, if you just feel like you want to challenge us on anything we're saying, you can step into the arena and just tell us that we are wrong, and then we will discuss that with you.
We don't view, our perspective doesn't allow us to view stars in the sky or anything else in a curve. We don't know more than we view streetlights in a row in a curve. The curve part is not from our perspective. It's added in due to the use of the arc scale. That's why they have the curve added in. It's an added in thing that isn't real. We don't have perspective that causes a curve. We don't have that. What we have is perspective that causes things in the distance to change in angle or size. We don't view things in a curve. We view things as a change in elevation or an apparent change in elevation in the distance or whatever, from where our feet would be, blah, blah, blah. But we don't view a curve. The curve part is added in due to the arc scale. It was added in. Not real. Nobody sees things in a curve.
Indeed. Why is it the case that in this diagram, the sphere can be absolutely ginormous with a relatively small by scale arc of the heavens around it, with a flat plane that's going to be used with the Dingleberry transposition to the centre of it, right? But this globe Earth is much, 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 much larger than this globe Earth. Why? Well, because it's irrelevant. It's surplus to requirements. It makes no difference if it's a giant globe Earth in the middle, with you measuring an angle out along this flat plane with the green dome above it, because you're going to be measuring it out to a point on this perspective representation of the star that you're looking at. Not to this tangent plane, to the centre of the presupposed spherical Earth with a random size. Well, that's not using the sphere. It's totally surplus to requirements. Again, in this one, same thing. Measuring an angle to a star, sod all to do with the globe Earth I'm going to dissect, even though they've rubbed out the line, and everything to do with this flat plane. So it doesn't matter. This could be all the way out to here, and you'd still be dissecting it and ignoring it completely. The sphere in the middle, I mean. Doesn't matter if it comes out to here, here, here. It's never used. The plane's being used to measure the angle. Yeah, that's your equatorial plane. So it makes no odds whatsoever. And that's why I said that the burger doesn't represent it. In this one, it does. So it's just a whopper, right? The equatorial plane is just the size of an oversized beef burger compared to the bun Earth, right? But then when it doesn't get across the point that it's so surplus to requirements that you can draw it at any size you like, and it makes sod all difference to the angle you're measuring, because the angle's coming off a flat plane. So this little tiny globe Earth in the middle of the slide we're currently on in 10th's presentation, you know, look how big the burger bun is for that. You know what I mean?
Can I say something real quick?
If it's about burgers, definitely.
Is it fair to say that the globe is irrelevant?
In this, it is, yeah. It's entirely surplus to requirements. There's no need for it. It doesn't do anything useful, does it? You tell me in this process, or as depicted on screen right now on the slide that 10th's got on, with South Celestial Pole, North Celestial Pole, vernal equinox, and the declination angle being measured from the centre of the sphere that isn't being used. The plane is. You tell me what use this is. The globe in the middle, I mean.
To keep people in bondage. That's all.
That's why they always show, and we've shown those slides, they have to draw a tangent plane on the surface of that irrelevant globe because it's not being used for anything.
Yeah, so they say that the angle that is being used, which comes from the centre, a la this diagram, right? The angle goes to the centre of the sphere. Well, they say, well, no, what we do is we draw out a great big flat plane that's got a globe Earth dangling below it, and then when we match it up to the measurements we're actually going to be utilising, we'll take it to the centre and have a giant plane extending out beyond the centre of that, and we'll call that the equatorial plane. And you're like, why? You can just take the angle from your position to a star with a flat baseline, and then plot it out on a flat map to give you your fix when you do 2 or 3 of them. Well, that in no way requires or necessitates anything being done with a sphere. And the sphere that they would suggest has been derived from this angle measurement to Polaris in the first place. This representation's been bastardized into a sphere. You can't make it work and function the other way. It doesn't work. So you end up with Dingleberry Earth and tangent planes being drawn, and then a claim that the light's all coming in parallel, so it's perfectly acceptable to assume you're standing in the centre of the rock that's spherical to make it all work. It's absurd. And the reason it's absurd is because the model's been derived from a flat plane in the first place, and when you navigate on it, that's what you navigate with. So there's no sphere involved.